All right, today we're going to start chapter 10, and 10.1 is over sequences, series, and sigma notation. So these are going to be just general sequences and series. Over the next couple of days, we'll look at specific types of sequences and series, but today will just be general. So for this first example, it wants us to find the next four terms of the sequence, 2, 7, 12, 17, and then find the next four numbers. So what you're looking for is your pattern. So what's the change in the numbers? And so if we look at these numbers, we can see that 2 plus 5 would give me 7, 7 plus 5 would give me 12, and 12 plus 5 would give me 17. So it stands to reason that we're going to continue to add 5. So if I do 17 plus 5, that's going to give me 22. Then 22 plus 5 would be 27. Then 27 plus 5 would be 32. And 32 plus 5 would give me 37. So there are the next four terms in the sequence. Nice and easy. Now take a look at the next one. Find the next four terms of the sequence, 2, 5, 10, 17, and on and on. So this one's a little bit more difficult to see. Not terrible, but it's not quite as obvious as the first one. So if we look at these numbers, from 2 to 5, just kind of look at changes that you see. And you may have to try a couple different possibilities. But if we look from 2 to 5, I can see that that is an increase of 3. Okay, well from 5 to 10 is not an increase in 3, it's an increase in 5. Okay, so let's keep going. 10 to 17 is an increase of 7. So although the change isn't constant, the amount that the change is changing by is constant. So we notice that we are adding 2 more each time. So we're adding 3, then we're adding 2 more, which is 5, then we're adding 2 more than that, which is 7. So then next, we're going to be adding 9. And so 17 plus 9 is going to give us 26. Then we would be adding 11, so adding 2 more. So 26 plus 11 would be 37. Then we would be adding 2 more, which is 13. So 37 plus 13 would give me 50. And then adding 2 more would be adding 15. So 50 plus 15 is 65. So those would be the next four terms in our sequence. All right, so now let's continue on. Now that's when we're given just a list of terms and we have to come up with what the pattern is and continue the pattern. Now we're going to look at something that's a little bit different. It's still a sequence, but it's written differently. We don't have the first so many terms given to us. What we have is a formula. So if we want to find the first four terms of the sequence given by A, we pronounce this A sub n equals 2 times n times -1 to the n power. Now, something we want to talk about that's really important is what this A sub n means. So, A sub n means the number of the term that you are looking for. So if you are talking about the first term, then that would be A sub 1. If you're talking about the second term, that would be A sub 2. The third term would be A sub 3. So if A sub 1 is the first term, then that means that in our formula for the first term, n would equal 1. For the second term in our formula, n would equal, n would equal 2. And for the third term in your formula, n would equal 3. So this little number down here is the value of n. So that A sub 1 tells you which term you're looking for and what your value of n would be in the formula. So it's really important that we understand that. So now if we go back over here, if I want to find the first four terms, that means that I want to find A sub 1, I want to find A sub 2, A sub 3, and A sub 4. Those would be my first four terms. And so I know in A sub 1, n is going to be 1. So I simply plug that into my formula. So I have 2 times n, which is 1, times negative 1 to the n power, and n is 1 again. So then I just need to simplify this. So then let's start with the negative 1. So negative 1 to the first power is going to be negative 1, so that's going to remain 2 times 1, and then negative 1 to the first power is negative 1. So then if you multiply those three numbers together, you just get negative 2. So our first term is negative 2. So I'm going to write that over here. We want to write it as a list. So negative 2 is our first term. Now we find our second term. So for our second term, we know that n is 2. So our formula is 2 times n, which now is 2, times negative 1 to the n power, which again is 2. And now we simplify. So we're going to leave the 2 times 2 for now, but then we have negative 1 to the second power. Well, negative 1 squared is simply positive 1, and so then we multiply that all together, and we get 4. So 4 is our second term. Now we do the third term. So in the third term, n would be 3. So we have 2 times n, which is now 3, times negative 1 to the n power, which is 3. So then we keep the 2 times 3, but then negative 1 to the third power is negative 1. So multiply that all together, and we get negative 6. So negative 6 is our third term, and we need one more. A sub 4 is our fourth term, and n is 4. So we have 2 times n, which is 4, times negative 1 to the n power, which is 4, and then simplify. So 2 times 4, and then negative 1 to the fourth power is positive 1. Multiply that all together, and we get 8. So that is our fourth term. So now we have the first 4 terms of this particular sequence. Alrighty, on we go. Okay, for our next one. All right, again, find the first 4 terms, but this time we have a new formula. A sub n equals n cubed minus 10. So remember, n is going to come from the number of the term we're looking for, and we are looking for a sub 1, a sub 2, a sub 3, and a sub 4. So 4 terms. So for the first term, n is 1. So then we have 1 cubed and then minus 10. Well, 1 cubed is going to be 1. And then minus 10 would be negative 9. So there's our first term, negative 9. Now for our second term, n is 2. So if I have n cubed, then that's 2 cubed, still minus 10. But 2 cubed is 8. Then we subtract the 10, and that gives us negative 2. So negative 2 is our second term. Now for a sub 3. So n cubed, that means 3 cubed minus 10. Well, 3 cubed is 27. Minus 10 is 17. So there's our third term. And then for our fourth term, n is 4. So we have 4 cubed minus 10, and 4 cubed is 64. Then minus 10 gives us 54. So there is our fourth term. So first 4 terms of the sequence given by this general formula. Alrighty, on we go. As we can see, these go pretty quickly. All right, now for this one, it says find the 5th term of the recursively defined sequence. Now, we need to pay particular attention to this because when it says recursively defined sequence, or anything that has to do with recursive, that's special. That means that you are going to have somewhere in your formula something like this. So notice, it's not just a sub n, it's a sub n minus 1. So let's think about what this means. So if a sub n, so let's say we're doing the second term. So that would be a sub 2. Then, so a sub n. So second term, a sub 2. Well, if I want to find a sub n minus 1, so then if n is 2, then finding the second term, that means 2 minus 1 would be a sub 1. So basically, what this means right here is that this is the preceding term. So if we're looking for the second term, then a sub n minus 1 will be the first term. If we're looking for the third term, then a sub n minus 1 will be the second term. So it's always going to be the term right before the one you're looking for. Which means, let me get rid of all of this for a second. Okay, which means if I'm looking for the fifth term, that means that n is going to equal 5. Well, if I'm looking for a sub 5, then that means I'm going to need to know a sub 4. But to find a sub 4, I'm going to need to know a sub 3. And so I'm going to keep going back and back like that. So anytime I have a recursively defined sequence, they're going to have to give me a term to start. I have to have something to start with, because every term I try to find, I'm going to be required to use the term right before that. So they're going to have to tell us one of the terms. And in this case, they happen to start with the first term, a sub 1. So we want to work our way up to the fifth term. So we know a sub 1. So with that, if I plug in a sub 1 here, that will allow me to find a sub 2. So a sub 2 is going to equal a sub n minus 1, which means the previous term. The previous term would have been a sub 1, which is 1. Then plus 2 times n. Well, since I'm looking for the second term, that means n is 2. And then minus 1. So then I'm going to simply do all that math. So I have 1 plus 4 minus 1, and that would just equal 4. So my second term, a sub 2, is 4. Now that I know what the second term is, I can use my formula to find the third term, and then I'm going to keep going until I get to the fifth. So now we can find a sub 3. So for the third term, we know n is 3. Now we want to start with a sub n minus 1, which means the previous term. So the term before a sub 3 is a sub 2. And we found that a sub 2 was 4. So that's going to be 4 for our a sub n minus 1. Then we're going to add 2 times n. Well, for the third term, n is 3. And then minus 1. So then that is 4 plus 6 minus 1. And then that will give us 9. So the third term is 9. So notice in each term, we're using the answer from the previous one. So for a sub 3, we used the 4, and it went right there. So now for the next term, we're going to use the 9. So our next term is going to be a sub 4, and we want to start with a sub 1, which is the third term. We found the third term was 9. So then we're going to take that 9 and put it there. Then we're going to add 2 times n. Well, since it's the fourth term, n is 4. And then minus 1. So we keep going back to this formula right here. Then if we do that math, we have 9 plus 8 minus 1. And that's going to equal 16. So we're up to the fourth term. Remember, we're trying to get to the fifth term. So we're ready finally. So a sub 5, that's our fifth term. That is an ugly 5. Let's try that again. 5. Okay, so for the fifth term, that means that this first number needs to be the previous term, a sub n minus 1. So that's going to be our 16 plus 2 times n, and n is now 5 because it's a fifth term, minus 1. So we have 16 plus 10 minus 1, and that's going to give us 25. So we wanted the fifth term, and we now have the fifth term, which is 25. So I'm going to write my answer that a sub 5, the fifth term, equals 25. So that is my answer. So anytime you see recursive, that means that you're going to be using a previous term in the calculations for your next term. So just kind of be aware of that. Alrighty. Now the next one, we are trying to find a partial sum. So it says the nth partial sum. So that means it's going to tell us to find the sum of the first however many numbers. So if it's the third partial sum, then we're finding the sum of the first 3 terms. If it's the 10th partial sum, then we're going to add together the first 10 numbers in the sequence. So they have given us the formula, and they want us to find the 4th partial sum, which means I need to find the first 4 terms and then add them together. So I'm going to start by finding a sub 1. So for a sub 1, that means n is 1. So my formula says that I'm going to do negative 2 to the n power, well in this case n is 1, and then plus 3. So let's simplify. Negative 2 to the first power is just negative 2, plus 3 would give me 1. So there's my first term. Now I want to do a sub 2. So now n is 2. So I have negative 2 to the n power, which is 2, plus 3. Well, negative 2 to the second power, or squared, is a positive 4. Then plus 3 equals 7. So we've got our second term. Now we want to do the third term. So a sub 3 means n is now 3. So I'm doing negative 2 to the n power, which is 3. Then I add 3. Negative 2 to the third power is a negative 8. And then plus 3 would equal negative 5. Now, 4th partial sum, that means I need one more term. I need the 4th term. So now n is 4. So I have negative 2 to the n power, which is 4, plus 3. Now negative 2 to the 4th power is a positive 16. Then I add 3, and that gives me 19. So I have the 4 terms, the first 4 terms, but I want the sum of those 4 terms. So I'm going to simply add those together. So 1 plus 7 plus negative 5 plus 19 is going to give me 22. So that is my 4th partial sum. Okay, so not nearly as hard as it sounds. You just have to know how many terms do I find and then add them together. All right, so the last thing that we're going to talk about for today is called sigma notation. Now, sigma is a Greek letter, and it kind of looks like a funky E, sigma, and it stands for sum. Those of us that have done any kind of programming or working on Excel or anything like that are probably familiar with that symbol, and that symbol means sum. So whenever you see that sigma symbol, you know that you're going to be adding stuff together. So this is just a fancy way of saying that you're finding a sum. You're going to find some terms, you're going to add them together. So this says that for any sequence, a sub 1, a sub 2, a sub 3, ... So continues. First term, second term, third term, so forth and so on. The sum of the first k terms is given by this. Now, we want to talk about what all of that means because it looks a little bit confusing at first, but it's really not bad. So basically, this is the formula that you're going to use. So that's not normally going to be a sub n. It's going to be some type of little formula, 2n plus 5 or whatever it may be. It's going to be some little expression that you have to plug into. And so you are going to plug in values of n. Now, how do you know where to start and where to stop? Well, that's given to you by the numbers on the top and the bottom. So you're going to have n equals, and then whatever that is. It may not always be 1, but whatever that number down there is going to be the first number that you plug in for n. Then, up here is going to be the last number that you plug in for n. And you're going to plug in everything in between. So we're going to start at 1, plug in 1, get an answer. Plug in 2, get an answer. Plug in 3, get an answer. All the way until we get to whatever number this is. If this number is 5, then you're going to plug in 1, then plug in 2, then plug in 3, then plug in 4, then plug in 5, and you're going to stop. Then you're going to add those all together. So these tell you your first number to plug in for n and your last number to plug in for n. And it may not always be n either. It could be another variable. So whatever variable is here, that's where you're plugging those numbers into. But it's always the first number you plug in, and then the last number you plug in, and then add all of your answers together. Okay, so let's take a look at some problems using this, and hopefully it will make a little bit more sense. So we have 3 problems in which we need to find each sum. So our first problem, we have our little sigma notation. We have here the expression that we need to plug into, and we know that we need to start by plugging in 1. So then we're going to plug in 1, we're going to plug in 2, 3, 4, and then once we plug in 5, that's the last term we'll find. Then we simply add all of our numbers together. So because we have a 1 here, that means the first thing we want to find is a sub 1. The last term we want to find is a sub 5, and we need to find everything in between. So we're going to do a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5, and then we're going to add all of those together. So remember what we're plugging into is this. So for a sub 1, we know n is 1, so that's 4 times n, which is 1, minus 3. Well, 4 times 1 is 4, minus 3 is 1. So our first term is 1. Now we find the second term. So for the second term, n is now 2. So we have 4 times n, which is 2, minus 3. Well, 4 times 2 is 8, and then minus 3 is 5. So our second term is 5. Now we find the third term. So 4 times n, which is now 3, minus 3. Well, 4 times 3 is 12. Minus 3 would be 9. So our third term is 9. Fourth term, n is now 4. So 4 times n, which is 4, minus 3. 4 times 4 is 16. Then we subtract the 3, and we get 13. So 13 is our fourth term. And now for a sub 5, n is now 5. So 4 times n, which is 5, minus 3. 4 times 5 is 20. Then we subtract the 3, and we get 17. So now, I want to take all of these numbers right here, and I want to add them together. So if I add 1 plus 5 plus 9 plus 13 plus 17, add those all together, and you're going to get 45. So the sum is going to equal 45. That's our answer. Now we're going to do the same thing with number 2, but we have a slightly more complicated formula to plug into. So for this one, notice we are not starting with 1 this time. We're starting with 3 and ending with 6. So remember, that tells us what numbers to plug in, not our answers. Those are what numbers we're plugging in. So we're going to start by finding a sub 3. Then we need to find a sub 4, a sub 5, and a sub 6 is the last one we'll find. So I'm actually going to erase those so I can give myself a little more room. But we know we need to find from a sub 3 to a sub 6. So for a sub 3, n is 3. So when we plug in, that's 6 times 3, then minus 3, and then all of that divided by 2. So in the numerator, 6 times 3 is 18, minus 3 over 2. Then 18 minus 3 is 15, divided by 2 is going to be 7.5. And it's okay if it comes out to be a decimal. It's a fraction. That can happen. I'm not going to require you to write this as a fraction. You can go ahead and do a decimal. It's okay. All right, so then we've got a sub 3. We need to find a sub 4. So n is now 4. So we have 6 times n, which is 4, minus 3, divided by 2. So in the numerator, 6 times 4 is 24, minus 3 over 2. 24 minus 3 is 21, still divided by 2. And 21 divided by 2 is 10.5. Okay, so we have the fourth term. Now we need to find a sub 5. So n is now 5, so 6 times n, which is 5, minus 3, all over 2. 6 times 5 is 30. Still have to subtract the 3. Still all over 2. Then 30 minus 3 is 27. Still divided by 2. And then 27 divided by 2 is 13.5. Okay, so we have a sub 5. Remember, we want to go up to a sub 6. So that means this is the last term we need to find before we add. So n is now 6. So 6 times n, which is 6, minus 3, divided by 2. 6 times 6 is 36, minus 3, divided by 2. 36 minus 3 is 33, divided by 2. And then 33 divided by 2 is 16.5. Now, I want to do the sum of all of those answers. So I'm going to take these answers, I'm going to add them together, and then that's going to give me 48. So our sum of those few terms from the third term to the sixth term is 48. Alrighty, then the last problem we need to do is going to look a little bit frightening at first, because according to this, I want to start with a sub 1, but then this says I'm never going to end. Well, how can I add something that never ends? Well, let's take a look. It's not going to be as bad as we think. So this is the formula we're plugging our values of n into. We know that we need to start with a sub 1, so let's do that. So a sub 1 is going to be 7 over 10 to the first power. Well, that's just 7 over 10, which would be 0.7. Okay, then let's do a sub 2. Well, a sub 2 is going to be 7 over 10 to the second power. So that's 7 over 10 to the second power is 100. And if we divide that, that is 0.07. Okay, let's do a couple more and kind of see what happens. So a sub 3, so we are going to do 7 over 10 to the third power. So 7 over 10 to the third power is 1,000, and 7 divided by 1,000 is 0.007, or 7 thousandths. So this is 7 tenths, 7 hundredths, 7 thousandths. So hopefully we're noticing a pattern. If not, we can do one more. So a sub 4 would be 7 over 10 to the fourth power, which means we are now going to have 4 zeros on the bottom. So that's 7 over 10,000, or we can have 7 ten-thousandths. So if we see our pattern, if we add these together, well, think, every term from here on out is just going to have one more 0 if it's following the pattern, which means if I add these together, even if I just add these, I'm going to get 0.7777, and it's going to continue, which means that no matter how long I list this out and add it, it's just going to keep putting 7s on the end. Now, I can actually write this in 2 ways. I can write that this is 0.7 repeating. No, do not round it, because we don't want a rounded answer. We want the exact answer, and we want to show that that 7 keeps going on and on and on forever. So we can write it as 0.7 repeating, or we can write that as a fraction, which would be 7/9. If you don't trust me, put it in your calculator. 7 divided by 9 comes out to be 0.77777, and on and on and on. So even though it looks like this is going to be awful because it says we're going forever, once you write out the first few terms, you can start to see your pattern, and then you can kind of just go from there. All right, so that is really all we have today for our general sequences and series, and then you have your homework to do. So you guys are going